Hello, welcome everyone. So let's get started because the time is short. I'm just gonna really show you guys the agenda here, and I will start live coding again immediately because this whole session is about live coding. Let's get started. My name is Peter Hausa. I'm with TypeSafe, and today I'm gonna demonstrate to you Play framework, which is the rapid application development framework, both for the Scala and the Java language. So I'm going to start a new Play application here. Demo 2. This is going to be the name for this, and I can choose between Scala or like a Java application. Which one should I choose? Scala or Java? Scala? Java? Okay, I think I'm going to go with Java, but I will make sure that we will cover Scala as well. So that's that, and let's jump right into this application. Okay, so this is the application layout. What you're gonna see here is like a pretty standard like MVC framework. You got your controller code defining the controllers package. You got your views defining the views package. What you see though, even though I chose like a Java project, you see those kind of Scala files. The reason is that Play's default templating engine is using Scala in their name, but you don't have to really learn the language just to an extent when you need to learn, say, JSP and any other templating language. So this is just used for templating, hence Scala there. You also get the standard configuration for your application, and the heart of every Play application is the route file. This is pretty standard stuff if you did Django or Rails before, like you define URLs and the corresponding methods there. And the only interesting thing here to note is that we also define like a controller that's going to serve assets. So you don't need like a separate web server to run your assets. So let's run the Play console because we're here to see a tool in action after all. So I'm going to fire up the console. Hopefully I will have internet. While doing so, I'm going to show you the build file, which is using a build system called SBT, but you can plug in any Maven dependencies you have, so that shouldn't be a problem. Okay, the console is up. Let's see what kind of Play-specific commands out there. Yeah, the other way around. So as you can see, there are a few commands to choose from. We will start with run, right? So let's run an application because we just created one. So let's see what we got. Okay, so I'm switching to the browser, hit refresh, and hopefully you'll see a Play application. On the console, you just see that the files are compiled the first time, and you get the welcome page. Okay, nothing fancy here. So let's go back to the application and try to make a change. So I have this controller method here, and assuming I'm just writing this controller method, I'm just going to make a typo here, okay? And I switch back, hit refresh, and oh, all of a sudden I see that there was an error. Yay, that's not too good. Let's see what happened. I see that like there was a problem there, so I have to switch back to the browser and fix the problem. So I have switched back the browser, switch back to my editor, save the file, switch back to the browser, hit refresh, and you see the page again. What's unique about this workflow is that the step I didn't execute was reloading and recompilation. All of these things was happening behind the curtain. Pretty cool. Now, the other interesting thing to note here is that when I just change the, so let me change the method name. Okay. So I just changed the method name from index to index1, and you can see that that the route file is also compiled. So what it means is that like if you make a typo in your RAD file, or like if the corresponding method is missing that you reference in your RAD file, then you're gonna get a compilation error as opposed to runtime error. This is also true for templates. So let me fix the method. I'm gonna refresh. It should be coming back up. Great. And I'm gonna simulate another error from the RAD file itself. So what happens if I make a typo here? I'm gonna see my favorite error page. That's not so good. Third time in a row. All right, so I fixed that. That's good. Whew. So the next thing that we can take a look at is the Scala-based template language. What you see here probably is very familiar if you did any kind of like standard templating stuff. As I said, the only difference is that you have to write Scala expressions as opposed to Groovy or Java or Ruby. The part that I would emphasize, though, is that because we're using a kind of like a static type language, we actually can compile templates as well. So I'm going to make a typo here, and switch back to the browser, hit refresh, and the screen that we saw a few times during this talk is there again. It's basically complaining about the title, so let me fix that. I fix the title, save it, switch back to the browser, hit refresh, and hopefully now it gets compiled. So not only the RAD files are compiled, but templates as well. Okay. So the next thing, yes. So let's see some integration with modern HTML5 client-side technologies. So the technology I'm going to demonstrate here is called Require.js, which is one of my favorite JavaScript libraries out there these days. And I have this demo application, another one, which I'm just going to fire up. Again, I launch the console, and then I run the application. And I will show you guys what's happening. So, the first thing that you notice if you use like Require.js before is that like you have to first kind of bootstrap your application. The way you do that, like you define like a standard like kind of like a script tag, and in the script tag you have to tell Require.js which is going to be the module that you're going to be working with. In this particular case, we're working with a module called main.js, which is kept inside assets here. So as you can see, a play application structure is pretty simple. So you get the app folder, and within that you get assets, controllers, views, and if you have models, then models as well. Within the JavaScript folder, we got main, which is requiring another library called library, which is just going to basically run this simple function for me. And that's pretty much it for Require.js. So the other interesting thing about Require.js, if you used Require.js support before, is that it has two modes. One is the client-side rendering, and the other one is the server-side optimization. When you're working with Play in this development console that I just showed to you, then the mode that you're using is the client-side resolution. So in other words, the dependencies that I kind of require being loaded to the browser on demand when I refresh the browser. But when you create like a distribution, which I will show you guys shortly how to do, once you create a distribution, then Play is running the optimization for you. So it means that like you will have to have only one JavaScript file for your whole module, minified and combined. So because I just mentioned that, let's demonstrate packaging. So the only thing you have to say if you want to create like a Play application is this. This is going to create like a zip file. It's very similar to like WAR files if you dealt with like the whole Servet model before. But the main difference is that like a Play WAR file, a Play distribution contains the runtime as well. So you don't need a specific container to run it. You just unzip the file and you can run the application immediately. I will show you the result in a minute. Now Require.js is running the optimization. Again, this is only necessary in server-side mode, or when you kind of packaging up for production, because in production, obviously, we don't want to make 200 HTTP requests, or depending on your number of JavaScripts that you're using in that specific module. So I'm going to show you this. So this is going to be the distribution that you can launch in production, and as you can see, it's just I can even show you the startup script. So the startup script is essentially just going to be like a standard Java process where the class path is containing all the libraries that my application is using. No extra container is necessary to run a Play application. So once I'm done with this application, say I can just give this zip file to the DevOps, and then they can just deploy as a standard Java process. If you use any of these kind of standard like Java monitoring tools, that you can also configure those, because it's just a Java process, so that shouldn't be a problem. So that was packaging. So let's go back to the demo application I just created. I'm going to go back. And one of the interesting things that you can also do from within the console is that you can look into your application. By that, I mean that you can actually observe what's happening inside, and I can play with the API. So I'm just going to start like a Scala console. Even though I'm working with like a Java application, the Scala repo can be really useful just to test Java APIs. So you can say, like stuff like demo, I don't know, something, and then replace. I don't know. Just so you can see that like you can even test like standard like Java APIs, but we're here to see Play after all. So let's just create a new Play application. So what's happening here is that like first I move like a Play application into context, and now when that's done, I can actually execute any methods for that application. So I just call this method from the console, and then you can observe the result. This is an excellent way to kind of try out your application while you're working on a new feature, or if you're just curious what's happening behind the curtain. Okay, so I just jump back to the main console. And let's see what else. Yes, and the next thing I'm going to show you guys is running test. Not surprisingly, running test is easy, so you just type test, and then all of the tests going to be executed. Now let's check out these tests. So the tests that are coming with the Play application cap here. As I said, I wanted to show like a Scala example as well, so this is a Scala test. You can test pretty much every layer of your application. So if you prefer a unit test approach, you can just create your unit test, or if you prefer like functional tests, then you can write your functional tests as well. The main difference is that functional tests tend to kind of test things in a kind of like a really indirect way, because many layers of your application will be exercised just by basically testing whether like I don't know, a certain page is rendered. Furthermore, in a functional test, you can also test JavaScript. In this particular case, we can see that we just created like a so-called like fake application, and in this context, we just execute like a method call and check whether the result is hello world. So we just this is the part where we just say that like, hey, tell me whether the result is hello world, and it was because the test executed properly. We also check a few other things about the request. So that's a typical unit test for controllers in Scala. Here is a Java version. The main difference is that we're using SAM types for test. Hopefully, once Java 8 is out, we can replace this with Lambda expressions. I certainly look forward to that. So it's not going to be as verbose as at the moment. Okay, and let's see a functional test. So as you can see, running a functional test is very similar. You have to just define the test server. What this means is that when you run a test, a whole application instance is being created, and then basically you can define what kind of browser you're going to use for your functional test. In this particular case, we configure like a headless browser called HTML unit, but if you prefer Firefox or Chrome or any other browsers, that should work as well. So let me try. Yeah, probably this is the easiest example. So what's happening here is that we just hit a certain page, and then afterwards we just check whether the page contains hello world. Here you can see a slightly more involved test, because not only can you just fire up like a whole test server, but you also can call the web services in your test. So what you see here is that we call this specific Play application using a web service call, and then we just check whether certain headers are there. The reason why it's done this way because the functional test runner that we're using is using WebDriver underneath, and that doesn't support retrieving headers. So in this particular case, the reason why we use a web service call as opposed to using the test runner is because of the lack of header support. But using the web service call, you can actually get access to headers as well. Okay, so that was that. I'm going to go back to the console. One of the interesting features that I would mention is that you obviously can generate like kind of like a project template for your favorite IDE, like Eclipse or IDE, but you also can run commands from within the console. So in this particular case, I just run like a git status, but this is not a git repository, so perhaps just running a simple ls makes more sense. And then again, once I'm done with the kind of my application, I can either package it with dist, which I just showed previously, but let's do it again just for this simple application. And or you can run an application in production mode just by going to the console and hit like play start. And if there isn't any other play application running in this browser, then it should work. So let me see. It's working. Yes. So my application is ready. So that was basically production mode. All right. And the last thing I would like to show you the other application. So the last thing I wanted to show you that like our template supporting like including other templates. So in this particular case, this particular template is including other template called main. So if I go to the main template, then you can see the layout for the main page. And the way you can refer to like a layout is just prefixing the call with an @ sign. And that will make sure that your layout for the specific page is included for the URL request. And finally, one extra feature that I think is worth mentioning is that the routes in your Play application can be referenced in a reverse route fashion. By that I mean that, for example, in this particular case, I didn't hardcode the URL for my JavaScript files, but rather I basically asked the framework to generate the URL for me. This can be useful if you have to reference both controller methods and assets in your application, because you can always avoid hard-coding URLs. Instead of that, you can just rely on a Play's reverse routing feature, which is basically getting the data from the routes file, which is this file. So just to recap, a Play application has like a pretty standard layout. The most important thing is the route file, which is defining the conf folder. You keep your application code in F folder. Within that folder, you get controllers, where you keep your controller methods, views, where you keep all of your templates, and assets, where you can keep your managed assets. Just like in this particular case, we kept the JavaScript files that were using require.js. And the way you can work with Play is that you can go to the application console, and then you can just hit run, fire up the application, and make changes to your source files without the need of like explicitly recompiling or reloading your application. I suppose that's it. Do you guys have any questions or one specific feature we should look into? Yes?
Are there some tests generated?
Yes, so when you, the question was whether tests are generated. So right now when you start like a new project, we include like a few standard tests, but in the future we will provide scaffolding as well, so it will be much easier to generate tests for your application.
But that's only for 2.1?
Yes. The scaffolding, the question was whether scaffolding is only for 2.1, and the answer is yes. Any other questions? Okay, in that case, thank you.